All right, here's our second lesson on factoring. And the thing we always want to keep in mind is that when we're factoring, we're being asked to find 2, 3, 4, whatever. We're trying to rewrite something as a product. So we're going to focus on trinomials today. We'll start with example 1. Each of these is a trinomial, which means they have 3 terms. So this first one is the easiest type because the coefficient of x squared is 1. So we know that when we factor that, the only way to get x squared would be to have x and x in each of the binomials that would multiply to give us that trinomial. Sorry, that's a stray mark there. Then when they're all addition, we know these have both got to be addition. So now all we need, the numbers here and here, we've got to multiply to give us the constant and add to give us the middle term. So we're trying to think of two numbers that if we multiply we get 24, but add to get 10. And those two numbers would be 6 and 4. And I can check this. I multiply this back together. See, I get x squared, 4x, plus 6x, plus 24. That will give us 10x, which would take us right back to where we started from. So we're just rewriting something as a product instead of as a sum or a difference when we factor. You try B. All right, for B, since it was just x squared, it had to be x and x. And then we need two numbers that multiplied to give us negative 45 and add to give a negative 9. Whenever that last term, the constant, is negative, your two binomials have to be different signs. The way you decide which one's negative is if the middle term is also negative, then the higher number has to be negative. You see that if you multiply negative 9 times positive 5, you get negative 45, but if you add them, you get negative 4. All right, so let's go to C. So for C, we have a coefficient of x squared. But since it is a prime number, the only factors of 2 are 2 and 1. That means it has to be 2x and x. That's the only way we're going to multiply those two and get 2x squared. And when I say the only way if we used integer values, integer coefficients. So now we need to figure out what numbers would go here and here to give us a product of negative 4. So if we think about numbers we multiply to get negative 4, they would be negative 2 and 2, or negative 4 and 1, and then we could change positive and negative. Now, neither of those will add to give us 2, because when we get that middle term and one like this, we also need to consider that coefficient of x squared. So we're just going to guess and check here. So let's say we try 1 and 4. So that would give us 2x squared. That would give us 8 and 1. That wouldn't give us the middle term of 2, so we know that's incorrect. So we would go ahead and change those and then try a different combination. So this time, let's see if I try 4 here and 1 here. So that would give us 2x squared, 2 and 4. I could get 2 from that. And I need a negative 4 when I multiply the last terms. So I know that one of them's got to be positive, one's got to be negative. Since I want the middle to be positive, I want this one to be positive and that to be negative. So see how that would give us 2x squared minus 2x plus 4x and minus 4. Those middle terms combine to give us positive 2x. All right, in D, we always want to look for a GCF. I didn't mention it, but I did look for it up here. 1, 10, and 24 didn't have any common factors, and there wasn't any variables in each term. So when we look at the one in D, notice we have this variable of x in each term. So that is a GCF. Also consider the coefficients. 8, 33, and 4, because of 33, which has only 33 and 11 as factors, there aren't any other parts of this GCF besides x. So we're going to factor that x out. See how if we multiplied this, it would just take us back to what was given in D. So now we need to make sure that we consider whether or not this part can be factored further. In other words, can we rewrite this trinomial as a product of two binomials? So we'd have to consider that. So now this one's a little more difficult doing guess and check, but think about this middle term as 33. We have 8 and 4. So when you're considering factors of 8, which are 8 and 1, 4 and 2, and then we got the 4 here, I right away want to try 8x and x, because I want to get to that middle term of 33. Then I'm going to try 4 and 1. Since these are all positive, I know this has got to be positive. So let's see if that works. That would give us 8x squared plus 32x plus 1x, which is 33x, and plus 4. So that is completely factored for that trinomial given in D. All right, here's a couple more examples. Let's do K. So when we look at K, I look at 15, 27, and 6. I notice that they're all divisible by 3. So I'm going to take out a common factor, or a GCF of 3. I can't take out an x because this last term is a constant. So see how this is just another way to write that original trinomial. So now I need to figure out whether or not this can now be factored. So when I consider 5 as prime, this isn't so hard. I know it's got to be 5x and x to get 5x squared. Factors of 2, I could either do 2 and 1 or 1 and 2. Since I need to get 9, I'm going to do 1 and 2 so that when I see how I get 10 and 1, that'll give me 9. Since I want the 9 to be negative, I want that. So let's try it. That would give me 5x squared minus 10x plus 1x, which does give me minus 9x, and then the last will give me a minus 2. So that is the complete factorization for that trinomial given in K. I want you guys to pause the video and try L. So in L, first thing you should notice is there was not a GCF. So you had to go right into your two binomials. And you could have tried 2x and 2x. I actually tried it, it didn't work. So then I had to go to 4x and x, and then factors of 6, 3, and 2. Our check, see how this will give us 4x squared plus 8x minus 3x and minus 6, which is 4x squared plus 5x minus 6. So you can see that this really comes down to really understanding the multiplication part. Alright, I'm going to show you for the last two here in the set, I'm going to show you a different method. And this is kind of just a structure for considering these. And what you do is you take the coefficient of x squared and your constant and you multiply them together and write it in the top. Then you write whatever your middle term is, that coefficient, on the bottom of your x. Then what you do here is you have to put two numbers that multiply to give you the top but add to give you the bottom. So that would be negative 5 and positive 1. They multiply to give us negative 5, add to give us negative 4. then you divide by whatever that number is in front of x. So we would divide by 1x, which is just x. So the factors are going to be x minus 5 and x plus 1. You see how that gives us x squared, 1x and minus 5x, which is a negative 4x, and a minus 5. All right, let's do n using that method. So we just make this x, it just kind of picks out the important numbers and information from this trinomial. So we do 3 times 4, and then we write the middle number of negative 8. So now we need to come up with two numbers that multiply to give us 12, but add to give us negative 8. So, how about negative 6 and negative 2? They multiply to give us positive 12 and add to give us negative 8. Now here's the step that a lot of people always forget with this method, which is why I just do the guess and check. You have to remember now to divide by that coefficient and x, so we're going to divide by 3x. If that can be simplified, you have to do that. So here we can take out a 3, so really it's going to be negative 2 over x. So your factors would be x minus 2 and 3x minus 2. So check it. 3x squared minus 2x and minus 6x is minus 8x, and then plus 4. So that is correct. Okay, I'm probably going to have time for one more example. So I want to go to example 2. Now these are still trinomials, but you notice the degree here is a little bit higher. So the idea works the same. Let's do letter B. So first we look for a GCF. Not a variable in each term, so no variable GCF. 2, 7, and 15 are not divisible by the same number. So this has got to factor into two binomials. Well, the only way to get, the best way to get this x to the fourth would be 2x squared and x squared. And those make sense given that our middle term has an x squared. Then we need to consider factors of 15. 7 and 3. I'm sorry, 5 and 3. So let's see if these would work. That would give us 2x to the fourth. That would give us a 10 and a 3. We could get 7 out of that. Since we want the 7 to be negative, that's got to be negative, and this has got to be positive. So let's see, we get 2x to the fourth minus 10x squared plus 3x squared, which is a negative 7x squared, and a minus 15. So that, and you should always check if these could then further be factored. In this case, this can't be factored anymore, and this is a difference, but 5 is not a perfect square. So that would be the complete factorization of that trinomial given in B. I want you guys to try C. Pause the video and try C. Okay, we look at what I got for C, x to the 6 and x cubed, so I broke it down into x cubed times x cubed, which is x to the 6. That would give us 1, and 8, which gives us the middle term of 9x cubed. 8 times 1 gives us a constant of 8 on the end. Alright, so go through and complete some more of these examples in each set.